Okay, good morning. What do we want to do today? Want to have fun? Have a pop quiz? That's fun for me. No, well, we have covered everything we wanted to. That was outlined in the syllabus. All the material has been covered, aligned very well with the labs, which has always been an issue, with the pacing of the class. So there's no more new topics. What I'm going to do today is review from the beginning, and then talk a bit about the final exam. Okay. So actually, let's talk about the final exam first. So the final exam page has been up on the Canvas website since the beginning of the quarter. There's also, let me bring this up here. Change screens, and let's see, new share. Okay, oh, not that one, wrong window. There we go. All right, so final exam page, as I stated, has been up on the front page on the Canvas website since day one. If you have not yet taken a look at it, please take a look. Read everything on this page. There are certain rules. But what I want to talk about is the options and then what's going to be on the final exam. So first up is that final exam is mandatory. It's not optional. It's worth 20% of your overall grade. Okay. So it's not 30, 35, or 40%. The point is, without taking the final, student cannot obtain a B or an A, right? You cannot have like the highest grade possible without the final. But if a student was happy with like a, I don't know, C plus or a B minus, then they could opt to skip it. You just, don't get the points of the work that you haven't done. So it's mandatory. It's not optional. There are 4 options for all 3 sections. Okay. So this is the university schedule day and time, right? This aligns with if I've made an error here, let me know, but I don't think I have. I've checked and double checked and triple checked multiple times. So these are the dates. These are decided by the university, okay, far in advance. Okay, so this is something that is not in my control. Exam takes place in this classroom at the times and the dates that are listed here according to your sections. There is also an option of taking the final on the Saturday before finals week, meaning the Saturday after next. And so a lot of students prefer to do that because they say we can get the 201 out of the way and then concentrate on our major classes during the week. It helps both the student also and me too, because I can get started with my grading as soon as possible. Otherwise, it's like Monday, Wednesday, Friday finals week. Then I have Saturday, Sunday, and Monday to grade like 1,000 pages and then submit the grades by Tuesday, which is, yeah, all-nighters. Okay, so that Saturday final is an option, right? It's an option available to all students. It's not mandatory. That's the first option. Then, depending on how many students from each section take the Saturday final, that many spots will be available on the day of the regularly scheduled final. And so if other students who have filled out the request since the beginning of the quarter wish to take the final at an alternate time, for example, you are section 02. So your final is on the Wednesday at 7 o'clock in the morning. Let's say you don't want to get up at 7 o'clock in the morning, which I think it's a reasonable excuse in my book. And if you don't want to do that, you wish to take the exam, you wish more time to study, you want to take it on Friday, which is fine. You can take it on the Friday, provided there are enough seats available in the classroom. So let's say 5 students from Friday's final exam decide to take the final on Saturday. That means I have 5 available chairs or seats on Friday. So then students who submitted the request can take it. Typically, I never have a problem because the classrooms are usually about 45, 50 seats. But this time around, I think I have 40 students in every section and only about 42 or 43 seats in the classroom. I'm going to try and see if I can pull in more chairs from the classroom next door, but that's not a guarantee. So if students have submitted requests, most of them might be approved because students are still, submitting requests for Saturday. So as we go along, this weekend and next week, I might have more requests, more students taking the final on Saturday, then I have more space during the finals week. So if you decide to do that, there is a form at the end of this page that you should submit. If you're taking the final on a Saturday, or if you're taking the final sorry, if you're taking the final at your regularly scheduled time, you do not need to submit this form. Okay. If you wish to take the final on a Saturday, submit the form, but you do not have to provide me any reason. You can just show up. Just let me know via this form that you are going to show up on Saturday. Okay. Also, you can fill out the form, say I'm going to come on Saturday and not show up. That is also fine. But don't show up on a Saturday without letting me know, because I won't have enough exams to print. That's the thing. Okay. So all students, if you are showing up on a Saturday, let me know in advance, because I will print the exams perhaps on Thursday night or Friday. Okay, Friday afternoon or evening by the latest. So then I need to know how many exams I need to print. So if you are coming on Saturday, do that, please. It's fine if if you wake up Saturday morning and you feel that you're not prepared enough and you don't want to show up, that's fine. Okay. Final exam information, comprehensive, cumulative, not optional, worth 20%. The comprehensive and cumulative is, well, I already stated that I'm not going to test you on AC analysis or AC power. I will test those topics on Monday, on our last quiz of our quarter, which is quiz 9, right? And I will post the details about quiz 9 just shortly. So AC analysis, we did the quiz. Quiz 7 was the problem for AC analysis. So in quiz 9, when I test you on AC power, there'll be concepts and certain calculations that you need to do, but it won't be like a full-fledged problem of AC analysis. Okay, there might be some calculations required. So that's why I said it'll be AC analysis plus AC power. But the weight of quiz 9 will be more towards AC power. Okay. So for that reason, I will not assess it separately on the final exam. Okay, so I will update this page, but since you're all here, I will let you know all in person also. AC power and AC analysis will not be on the final exam. Secondly, filters, we just tested in quiz 8. So I will have filters as like frequency response. Chapter 6 will be on the final exam, but it'll be mostly concepts or concept-based questions, mostly short answer questions. Okay. And again, all of this will be on this page. It will be reflected on this page. I will update this page. This is a decision that I just took last night. Okay. And so I will update this page. And this is very important. Students must solve using a particular method if the question states so. Okay. We are required. So we are mandated. We are accredited by ABET, right? ABET comes in, reviews our program every few years, which we are preparing for a site visit coming up next year. Then we have course outcomes. Course outcomes, we define syllabus and the expected course outcomes in every syllabus. We are required to teach students those topics. Then we are required to assess a student's knowledge about those topics. So if I ask you, well, if any professor asks you for a problem or a question regarding a particular method, you have to show your knowledge and skill regarding that particular method. So if I ask you to solve something with node voltage analysis, you have to show me your knowledge of node voltage analysis. Otherwise, I have no basis for assessment. Does that make sense? This is something I stated on the first day of class. This is advice that is generic to everything. Okay, if a professor in any class asks you to solve it using particular topic, you have to display or show your knowledge about that particular topic. Okay, so if you choose superposition to solve it, I can't give any points to that. Partial credit, I do award partial credit. So if your methods are correct, your steps are correct, your analysis is correct, but your calculations are incorrect and your final answer is wrong, you do not get a 0. You do get partial credit. And I lean more towards the side of the student, meaning if they showed me the correct steps and the correct methods, you do get a majority of your points. Okay, depending on where you made the error. If the error is like right at the final answer, you might just lose like 1 or 2 points, not like 10. Okay, so it depends where in the process you make an error. So again, take it step by step, outline all your steps, show me all of your work. That's why I keep harping, show all of your work so you can get partial credit. All right, and then units. Points definitely will be deducted for missing and incorrect units. Okay, that always, that's good advice for all engineers. Okay, topics. One big problem running into 4 pages would be about 30, 35 points that will test chapters 1 and 2. Okay, it's a combination of everything in chapters 1 and 2. It will test everything. Ohm's law, KCL, KVL, node voltage, mesh current, network theorems, Thevenin and Norton, which again I will review today. And then one problem from chapter 3, and I'm letting you know right now, it'll be based on physical construction of capacitor and inductor. Again, this is there on the final exam page. Piecewise linear analysis, I haven't decided yet, maybe, maybe not. So again, when I update the page, I will post an announcement. You can go and check the page, and then, well, it may or may not be on there. Transient analysis, one problem, and then that's it. 1, 2, 3, 3 problems. I would say 1, 2, 3, 4, 5, maybe 6 pages total. 6 pages total, 2 hours and 15 minutes. That's more than sufficient time. And then let's see, prep would be in-class solved examples, all the quizzes, homework, lecture slides, notes, videos. Equation sheet. I will delete that. And I will say that I will make it open book, open notes. I just haven't decided yet whether that open notes would be open laptop and open tablets, because there's an obvious issue with having a laptop or tablet. I cannot monitor everyone's screen. So I need to think about that. But again, rest assured, it's going to be open book, open notes like quizzes. Use all the tools you have at your disposal. Show me your best work. Okay. So if it's no laptops or no tablets, then maybe just print out everything that you need and bring it with you. Something like that. Sounds fair? Okay, that's it for the final exam. So once I update this page, you can review it again over the weekend and then send me any questions you have. And again, after hearing this, maybe a lot of students might decide to take the final exam on Saturday. Read through the rules. Everyone needs to present a valid Cal Poly ID to obtain the exam, and then when they turn the exam back in. So if it doesn't match up, then your exam will not be graded. Okay. This is to ensure, again, both ways, that the actual student who belongs in the class is taking the exam. And then when you submit it, it goes directly in my hand. So you have receipt that you have submitted a written exam to the instructor. Okay, that way there are no missing exams, and no one can come back later and state that there are any issues. So please read the rules. Okay, any questions for now? No? Okay. All right, then let's see what else. Talked about final exam, talked about quiz 9. And then I think that's about it. Let's go. Okay, chapter 1. If I summarize this, I would say that the only 3 equations we actually need are basically Ohm's law. Ohm's law is V equals IR, and then KCL, and then KVL. These are the only 3 equations we use to solve all circuits. Everything else is derived from these 3 equations. And then there's, of course, the 4th equation for power, P equals VI, right? Everything else is derived from these equations. So you have Ohm's law, you have KCL, you have KVL. So we learned about these in chapter 1. The reason for all those homework assignments in the first week was because, again, students need to brush up, but they are an important part of this course. Okay, the entire course is based on these equations. Because when we get to chapter 2, we derive further techniques, and those techniques are built off of these 2. So Ohm's law, KVL, KCL are the most important. Then, oh, then we had resistors in series, resistors in parallel, and then finding REQ, equivalent resistance. This is an important part. What else? And then was our first technique to solve for resistive circuit analysis was series parallel equivalence, where we take a large network or large circuit comprising of a network of resistors, and we reduce it down to one single resistance. We apply Ohm's law, and we determine the current or the voltage in the circuit, and then expand it back up step by step. So again, Ohm's law, KVL, and KCL was used to solve or use this technique or implement this technique. And then after that, we had voltage division, current division. Voltage division and current division are shortcuts. They are shortcuts based on Ohm's law. Okay, voltage division and current division are shortcuts. They are shortcut techniques that are based on Ohm's law. So again, the foundation of everything is what we learned in chapter one. And this will be there on the final exam. I'm letting you know right now. Voltage division will be there on the final exam. Current division will also be there on the final exam. Okay, guaranteed question. All right, then we get into the meat of the techniques. We had three techniques: node voltage analysis, mesh current analysis, and superposition. All three of these techniques are based on the previously learned techniques. Again, node voltage analysis requires application of KCL and application of Ohm's law. So again, it's a technique that utilizes the previous two laws, Ohm's law and the current law, Kirchhoff's current law. Okay. So again, node voltage analysis, mesh current analysis, and superposition principle, they're all based on the previously learned laws and techniques. Guaranteed on the final exam, node voltage analysis, guaranteed. Mesh current analysis, also guaranteed. Worth at least 8 or 10 points. And again, this is already there on the final exam page and will be reflected again. So it's there on the final exam page. So this is an important slide, how to proceed step by step, because this is how I will assess. Consider this as the rubric. Consider these steps as the rubric. Okay. So when I assess your problem, the work that you have done, the work that you show me should follow these steps. The steps are not all there, points will be deducted. Then supernode, I'm not going to test it separately. If you wish to do it, it's fine. It's a technique, right? It's not required. Again, supernode is also kind of like a shortcut. Supernode and supermesh are both shortcuts. So I'm not going to assess them separately. If you wish to apply it, that's fine. It's up to you. And then, of course, mesh current analysis. Mesh current analysis is also guaranteed on the final exam. Okay, one problem guaranteed. Mesh current analysis is based, again, on KVL and Ohm's law. Same laws and equations that we learned in chapter 1. So same new technique, but based on the same laws that we learned previously. And then again, consider this as your rubric. Everything that I have shown here should be marked on the problem. It'll also state that in the exam page. Okay. Mesh current analysis. Again, super mesh. I'm not going to test super mesh separately. And then superposition principle. I haven't yet decided whether I'm going to include it or not, but I will tell students that you have to study superposition principle. Okay. And this is not going to require you to do an extra study outside, because you will learn all these techniques as part of node voltage, mesh current, and Thevenin Norton anyway. Superposition is exactly the same thing, right? Superposition is breaking up a circuit into multiple pieces. And the way you break it up is by reducing sources to zero. So that's a concept that you need to know to find Thevenin resistance anyway. So you break it up into individual pieces, and then you can apply series parallel equivalent analysis, which is something that you'll already be studying anyway. Okay, so that's superposition, the three techniques. Equivalent circuits, okay, the main goal. So this is not a new technique. This is a concept. They are theories, they are theorems. Thevenin theorem and Norton theorem. So as I stated, this is going to be a 35 point problem, like a large problem. Everything else will be tested within this problem or as part of this problem, okay? The way this chapter is built, you learn about smaller techniques and it builds up to Thevenin Norton as a large concept. And that is how I will assess it. Okay, you will have a problem. That problem will require you to solve the Thevenin and Norton circuits. And then as part of your analysis of the Thevenin Norton, you will show me node voltage, mesh current, superposition, and so on and so forth. And that's why I said it's a large problem, but it's again the same circuit and you're analyzing it multiple times. So Thevenin and Norton equivalent circuits, everything is here. You should be able to answer these. And again, it's open book, open notes. So if you do get stuck, you have help and assistance that you might need. But they are only tools at your disposal. You need to know how to use those tools. Okay, if you have the tools available, but you don't know how to use them, then it doesn't matter how much time, how much time is provided to you. So Thevenin Norton equivalent circuits, kind of important points here. Review everything. Let me know if you have any questions. And source transformation, I'm not going to test. It's a concept you should know and be aware of. Some students do like to use it. I've seen about 3 or 4 students try to use source transformation in the final exam. I personally try to avoid it because for some reason I haven't been able to get a good grasp on manipulating circuits and source transformation. And so I generally tend to avoid it. So again, I'm not going to test you separately on this, but if you wish to use it as part of your analysis, that's fine. And maximum power transfer theorem, again, I'm not going to test that separately, and that's it. Chapters 1 and 2. That's the bulk of your exam. Okay, after that is just physical construction of capacitors and inductors. Oh, and capacitors and inductors in series and parallel. So I will add that also in chapter 3. In chapter 4, transient analysis would be one problem. So let's go over to chapter 3 first, and then we'll go to chapter 4. So chapter 3, inductance and capacitance. When we talk about physical construction, this is the slide, right? Physical construction of the inductor, and then physical construction of a capacitor. This slide and equation, okay? It'll be up to you to determine from the physical dimensions the value of the inductor and the capacitance. And then inductors in series and parallel. Right, there are homework problems regarding adding up inductors and capacitors in series. And so these concepts. And then again, piecewise linear analysis, if I decide to have that on there, then it'll be like a short section, not a big problem. Okay, And then chapter 4. This is it. This is all you need to know. One equation. Doesn't matter whether it's charging or discharging. Doesn't matter whether it's an inductor or capacitor. You just need to know this equation, and you need to know how to use it and apply the concepts. So it'll be one problem, and then that's it. 3 quantities: starting voltage or current, ending voltage or current, and the time it takes to transfer the energy. If you figure out how to manipulate the circuit, redraw the circuit as many times until it starts to make sense, and then directly write down the solution. Okay. All right. And then, of course, I'm not going to test you on these charts, but these are, again, basic concepts that students should be aware of. So this is the universal time constant chart. And then, of course, the values. Values, of course, just list, but you can easily calculate it. It's e raised to -1, e raised to -2, 3, 4, 5. You can easily calculate those. And that's it. That's all there's going to be on the final exam. All right, questions? You all ready for Monday?
Professor,
Yes.
I have a quick question. You said before, if we have a tablet, we have the notes on our tablet. You said we would need to print it if
Yeah, I haven't decided how I'm going to do that, because again, obviously, if somebody brings a laptop on there, I cannot monitor what students are doing on their laptops or tablets at all times. There'll be about 30, 35, 40 students on there. And so to have a level playing field for everyone, I mean, I know I allowed it for the quizzes, but I don't know how I'm going to do this for the final exam. So does that answer your question for now?
yeah, that answers. Thank you.
Okay. All right. Any other questions about anything? Okay. Well, let's end class here today. Let's end the quarter here today. We'll meet one more time on Monday for your quiz 9. And then Wednesday and Friday, no class. Enjoy, catch up on sleep, do some work, catch up on your assignments. I'll be in my office. I'll be on campus every day, 8 to 5, 8 to 6. And then if you need to stop by, if you have any questions, come by anytime you want. Just look at my schedule and I'll be happy to talk to you. All right. Good luck with everything. And I hope you learned something. If not something, at least Ohm's law, KCL, and KVL. That'll hold you in good stead. That solves everything. All right. I will see you all on Monday. I will be in my office later this afternoon between 1 and 2. At 2 o'clock or after 2 o'clock, there's a seminar I'm attending, so I won't be there till 2:30. I will be there till 2 o'clock. All right. It's actually an interesting seminar if you all want to join in. It's an E department. There's a former chair of the E department. He's talking about the equations that we teach to students and some of the derivations and why we do it and we should not skip it or something. So, all right. It's in the E faculty building, building 20A, in the lobby of 20A, the E department office. Yeah. If anyone has any questions, the meeting is open.